This next section deals with a formula basically called the combined gas law. And there's a very simple reason why it's called the combined gas law. What it actually does is it combines the formulas for Boyle's law, and this is the formula for Boyle's law. It combines that formula with the formula for Charles's law. And here's the Charles's law formula. And what I mean by combines is that it does the following. This is the formula for the combined gas law. It's V1, the initial volume times the initial pressure divided by the initial temperature is equal to the new volume times the new pressure divided by the new temperature. And if you look carefully at this, you will see the pieces of Boyle's law and the pieces of Charles's law. So here, I've highlighted in the rectangle here, that is the formula for Boyle's law. And Charles's law is shown here. V1 over T1, that's this part of Charles's law, is equal to V2 over T2. That's this part of Charles's law. So that's the formula for the combined gas law. Let me go back for a second. And what I should point out to you, in addition to the fact that you don't need to memorize this formula either. Again, I will give you all of the formulas. The combined gas law basically allows you to figure out what will happen to a gas in a container if you change two of these three features. In other words, if you change the volume and the pressure of a gas in a container, what happens to the temperature? If you change the volume and the temperature of a gas in a container, what happens to the pressure? Or if you change the pressure and the temperature of a gas in a container, what happens to the volume? This formula is a little bit more complicated, and many times it's not possible to look at the information in the question and intuitively figure out what is going to happen while you change two of those three things. The problem is that two things are changing now, and so sometimes it's harder to intuitively figure out what's going to change. So for the most part, usually you just sort of go with the formula here and try to figure out what changes mathematically. So on the next slide, I'm going to show you a sample problem from your book. This is, the combined gas law problems tend to be a little bit more complicated. So again, all you really have to do though is follow carefully what is being stated in the problem and plug in the correct numbers into the correct spots. So a sample gas has an initial volume of 158 milliliters, so this is V1. An initial pressure of 735 millimeters of mercury, that's P1, temperature of 34 degrees Celsius, and remember that we need to convert this to Kelvin. And then they say if the gas is compressed to a volume of 108 milliliters. So they're reducing the volume, so this is V2, and it's heated to a temperature of 85 degrees Celsius. So you're decreasing the volume and you're increasing the temperature. And again, remember you have to convert this to Kelvin. What's the final pressure in millimeters of mercury? So basically, what you need to do is you need to go along, and it might be helpful to write a little table like this and say, what is V1? And fill it in here. It's 158 milliliters. What's T1? It's 34 plus 273. What's P1? It is 735 millimeters of mercury. And then you do the same things for V2, T2, and P2. You just look through the problem and find the pieces of information that you know. And there will always be one piece of information that you don't know, and that will be the thing that you are trying to solve for, the thing that you're trying to figure out. The other thing to point out here is that there are a lot of different numbers running around here, and you should make sure that the units match up. In other words, we have P1 equal to units of milliliters. V2 is also equal to units of milliliters, so they match up and everything is good there. If they didn't match up, if this was given to you in liters and this information was given to you in milliliters, you would have to convert one or the other to the correct unit type to make sure that the equation worked out properly. But in this particular problem, the one that I chose, all of the units match. We have milliliters and milliliters. We're going to have to convert to Kelvin and Kelvin, and we have millimeters of mercury, and we have what's the final pressure in millimeters of mercury. So all of the units match. So there's the formula for the combined gas law. V1 P1 over T1 equals V2 P2 over T2. We fill in the pieces of information. This is V1, this is P1, this is T1, that's the temperature in Kelvin, after we converted this to Kelvin, is equal to V2 times P2, and we don't know what this is, so I put a question mark here, divided by T2, and this is just converting 85 degrees Celsius to Kelvin. And so all we really need to do now is cross multiply and divide to figure out what this question mark here is on the right. So I'm just bringing the problem over to the next slide. This is just me rewriting the same formula that I showed you on the previous slide. And basically figuring out what the question mark is, it will be 158 milliliters times 735 millimeters of mercury times 358 Kelvin divided by 307 Kelvin divided by 308 milliliters. And if you look at this, all of the units cancel out except millimeters of mercury. Milliliters on the top, milliliters on the bottom, they cancel. And Kelvin on the top, Kelvin on the bottom, they cancel as well. The only unit we're left with is millimeters of mercury, and it will turn out to be 158 times 735 times 358 divided by 307 divided by 108. And that turns out to be about 1,250 millimeters of mercury. I think I might have rounded in this case, but suffice it to say that this is pretty much close to all of those numbers multiplied and divided in the appropriate way. So if we decrease the volume to 108 milliliters and we increase the temperature to 85 Celsius, the new pressure of our gas in our container will be 1,250 millimeters of mercury. And that's the combined gas law. The combined gas law is probably one of the more complicated gas laws, but again, all you really have to do is make sure you place the correct numbers in the correct areas in the formula and make sure that all of the units match up, and then it's just a matter of cross multiplying and dividing. So the combined gas law, just to emphasize, basically tells you what happens to gas in a container if you change any two of the three features of pressure, temperature, and volume.